little demo, talk about the app architecture and some considerations that I had when building this app. And then I'm going to kind of talk about the SDK itself and some best practices that kind of show how to use maps in our SDK. And I'll talk a tiny bit about testing and then finish up with a lessons learned slide and a list of resources. So really the story is, where does this journey begin with an ocean mapping app? And if you think about the fact that 97% of our water comes from the ocean, and 70% of the ocean, or 70% of our Earth's surface is covered by oceans. And oceans are incredibly important in driving climate and weather, and affect our lives, and indirectly perhaps, but certainly affect it. And yet, despite this huge impact of the oceans on our lives, only 5% has been explored. And if we're going to kind of manage the ocean in the face of overfishing, pollution, natural resource utilization, we want to have enough information to make the right decisions about managing and protecting this ecosystem. So that gives you a little bit of context as to why about oceans, but maybe more to the point is, how do we go from ocean data to ocean maps? And Esri collaborated with a number of agencies, including NOAA, which is the National Oceanic and Atmospheric Administration Agency. And that agency is a government agency that does a lot of research on climate and oceans. So NOAA had accumulated many, many data points over the years about the ocean that they had collected every 27 kilometers around the ocean, around all the oceans, and not only on the surface, but all the way down to the bottom of the ocean. So we have this really rich data set. It ends up being about 52 million data points. And working with USGS and Esri, they together defined ecological regions in the ocean that share similar temperature, salinity, oxygen, and nutrient levels. So why do we care about those factors? What's important about those particular measurements? Well, those are things that impact ocean life, and those are things that will affect how our ocean responds to climate change and impacts on the ocean in different ways. So this app was built to kind of raise awareness about ocean health. It was also built to raise awareness about the fact that this is an open data set available to anyone who wants to build an ocean app, use the data for other reasons, integrate it with apps they might have. This also, we also built this app to serve as a mobile counterpart to an existing web app. So we're really trying to spread the word in terms of education and data and understanding. And then, of course, to showcase the ArcGIS Android SDK, which is what this was built with. So I want to talk a little tiny bit more about the science behind this and how it's organized, because the physical picture will help you understand what the app is doing a little bit. So on the far left, we have kind of 3 columns of water, kind of indicating, representing what a column of water would look like from top to bottom, ocean floor, and all the measurements that have been captured by NOAA over the years for different things. And what they found when they started doing this analysis is that they were able to statistically cluster groupings of measurements that had the same characteristics. So for example, they found that the region at the top in pink had shallow, warm, normal salinity, moderate oxygen. And then as you move down the column, you had different characteristics. At the very bottom, you had deep, very cold, normal salinity, moderate oxygen. And this was not an order that was always maintained. These are just examples of the types of characteristics and categories of measurements that they could kind of classify. What you end up with is, if you kind of imagine 52 million columns across the ocean that have been kind of characterized in this way, you have a multi-dimensional data set. You have both a column of water where you can traverse the depth and see how things change, and then you can also go across and see how the layers themselves change with geography and location. So the code is available on GitHub. The app is on Google Play. Again, the data itself is also available as an open data set from Esri. And I thought I'd try and do a demo with the app, so bear with me here as I as I do that. Let's see. So when you first start the app, you're presented with a map of the world and all the oceans, and you'll notice the different colors of polygons on the ocean surface here. And these are representing those different regions that have been classified in different ways by nutrient or physical properties. And so right now we're seeing the surface of the ocean, and we can start to kind of investigate what happens when you start to kind of toggle this and travel, move beneath the ocean surface, because all those layers start to change in content kind of across the globe, and we can start to understand how different regions reflect different types of properties. And so scientists might be interested in understanding, well, how does this one region change with depth, or also across the whole world, across the oceans, how is this particular layer, how does that change and move and influence animal life and animal observation. So you can think about how this data will be used in coordination with other types of data, like observations of dolphins or whales as they're migrating, and how does it change with depth. So let's see. We can also do a search. So this is backed by the World Geocoder. So one of the deepest part of the ocean is the Mariana Trench. It's about 10,000 meters at the deepest point. So I can start to type in and it's not being very responsive. Okay. So here we zoomed straight to the Mariana Trench. You can actually see the kind of curve of that trench, and it picked a place that it knows as the Mariana Trench. It may not be the most deepest part, but we can see it centered in the map, and then we can start to see detail about that location. So I can pull up the bottom sheet here and we see that this column has, first of all, we have a kind of a summary of the location, and there are 8 different distinct layers in this one location at this one point in the ocean. So it's got these different colored regions on the left are different portions of that column. So you can start to navigate down and see how physical summary, moderate depth, very cold, normal salinity, very low oxygen, high nitrate, medium phosphate, and then you start to see low oxygen, high nitrate. So these types of things are changing with ocean depth. Again, this is just another way to see the data. And so you can navigate the column by just clicking on it, or you can page through it using this button here, which actually just flip it up, and you're starting to kind of navigate up and down the column. Now there's more detail behind this, as I mentioned. You can start to actually delve into individual statistics for the column. So here we're showing a temperature of 8.29 degrees Celsius for that particular segment in the column. And then you can see kind of the blue bar shows kind of the low and high for that particular section across the globe. And then the black lines are the ocean averages. So you've got kind of a specific measurement in the context of various other larger contexts to help you understand areas of interest or just traits that might be interesting to follow up on. And then, of course, another view of a similar data is to kind of start to look at how these measurements change with depth. So we have temperature that kind of falls off pretty quickly in the first 1,000 meters, and then gets very close to zero as you get close to the bottom, which you would expect. It's going to be pretty cold at 5,000, 6,000 meters. And you have salinity, you have oxygen. So again, just another way to look at the data. It's a pretty multidimensional data set, and so it gets pretty complex pretty quickly. And this is a pretty small app, so it doesn't really, it just shows data. There's no data saving, there's no data writing or editing. It's just really an educational app to kind of showcase what our oceans consist of. So let's go back to the presentation. So let's talk a little bit about the app development, or app development patterns. It's great to hear about other people who are using MVP or MVC or MMVM. Being new to Android, I was kind of curious what the tool set was like out there. I had used MVC as a Flex developer for many years and found that I really liked the way it separated the code base. It was easy to jump in. If you use the same pattern across your apps, it was really easy to kind of get up to speed and start making changes if you had to because you were familiar with the pattern. So I figured there must be something similar for Android, and of course there is. One of the places that I found a lot of help from to get me started was the Android Architecture Blueprint repo, which has been mentioned several times today. This was great because it showed how to take an application and use different kind of architecture approaches, and it was really great because you could see how to use Dagger or just MVP or RxJava with MVP, so it was a great place for me to start. And so as you know, a view in this case is I treat the view here as a very passive view. It's just responding to events in terms of broadcasting events, and it's being updated by the presenter. The presenter is the one that's kind of where all the application and business logic is. And then the presenter is talking to the model, and the model here represents the database or the data services and the model objects. And it's pulling data down from the database or the data services and in response to what the user does. So, of course, there's obvious benefits to this type of architecture. It's easy to change, it's easy to understand, it separates concerns really well, and makes it very extensible. And so this felt like a really good choice. And so I continued on with that logic in mind. And so this is an example of one of the activities, the map activity, which is central to the app. I have a map fragment that encapsulates the map view. And then I have an interface that defines how the presenter and the map view interact. So in other words, the map contract has a view interface and it has a presenter interface. And this will allow me to kind of swap in mocks or other fakes, for example, for testing. And I went with the activity fragment approach as opposed to just activity or fragment because, again, I'm starting to build an app for really one of the first times, and I'm just going to follow what the best practices that I know about, that I had read about. And according to Big Nerd Ranch, we should use activities and fragments. So. And then, of course, you have interactions with the data manager that the presenter, again, is pulling from. And the data manager here is actually a class that I have called data manager. And it's building objects, model objects, based on the interactions that the user is doing in the interface. And it's interacting with services. Now, in our SDK, we're not using retrofit, even though we're interacting with a HTTP service. All of that is wrapped into our SDK itself because there's some particular types of things that you can do for spatial queries, and we just kind of provide all that for you in the SDK, and we'll talk about that in a bit. So kind of, again, extending this further now, I thought, okay, one activity fragment presenter, one MVP piece per screen. That seemed to make sense. That seemed to be logical. And so I kind of set out to do that. And what I found is that while this made sense, it wasn't very, the map was not very responsive. The map is a complex view. It inherits from Android views, so it's not like a strange thing in itself, but it does have a lot going on. There's rendering, there's data being pulled down. And in this architecture, I'm destroying the activity every time I move away to a different screen. And so when I come back to the map, I have to recreate the map. And it's an expensive thing to do, to recreate the map and reinstate that state that I lost. So that became kind of thorny. It wasn't really responsive. It wasn't it felt like a little clunky. So to get around this, I use one activity where I only ever have one activity. I don't go through any kind of recreation of activities. And this way, the map remained responsive and very interactive and snappy. And I was able to kind of navigate back and forth just using one activity. But then I had to kind of take responsibility for view switching and navigation all within one activity. And while that seemed to work in this small app, it probably wouldn't work so well in a larger app. So this kind of works in this context, and I just kind of wonder how well it would work in a larger app that had more screens, for example. because that logic is going to get away from you pretty quickly if you're just having to do it all in this one main kind of controller class. So let's talk now about the mapping patterns. And this is a nice transition point because just like we were working with MVP in the architecture in the app, we're also working with a component that has that same notion. We have a map view, which is an XML layout file where you define your map view, or you can programmatically define it or dynamically add it to your app. It's responsible for showing you the content of the maps. It's the view that you see in the app, and it extends from the view group, so it has a lot of the same things you would expect, like responding to touch events. It's responsible for loading the data into the view. And then, so that's the V and the MVP, and then we have the map, which is the model. Here we're seeing 3 different layers. And this is really just organization, layers of data. So the map and the model is about data, and how you organize your data really depends on your app. You can have lots of complex data that you need to keep separate for different types of reasons, and the same thing goes for maps. You have different types of map data that you want to kind of keep together and thus logically separate. Here in this SDK, location is a first-class citizen. So you're able to do spatial queries. You're able to represent location with data that has been geotagged, for example, and it does this just automatically. It's the model piece kind of talks or is about how that data is organized, and it allows you to both do spatial and non-spatial queries, and we'll talk some more about that. So is that clear to people? Does that make sense? Questions? Yeah, this composes the data pieces.
So the model is
The model is everything, so it's really like data and model are really equivalent here generically. And this just indicates the different types of data you may have in your app. And just like in a database, when you design tables, you have data segregated for particular reasons.
So this would be your chart and your detail and your map as the layers, right?
No, this is really looking at just the component that is responsible for viewing the map. Just taking that one component, the Android component, and there happens to be a view, and there happens to be an M kind of in this one component. And so this actually is part of the SDK itself, as opposed to part of the larger architecture. So in terms of data services, what kind of things are backing this app? We have, as I mentioned, we can query with the data layers we have. We can set up our data layers that are both spatial, so they have a sense, they have a notion of location and geometry and geography. And then you can have non-spatial data that's purely just numbers, or like a normal table you would have in a database that doesn't have any location data. And so here is where you can kind of start to map the spatial layers to each of the graphs. And this data set is again, really very three-dimensional, and I try and render that here. If you look at each of the columns, you can query it from top to bottom, but you can also query it horizontally. And so the horizontal kind of querying is the polygons that we navigated as we navigated to the bottom of the ocean and back. And then, for example, the first two over there are really about the content of the data, or the content of the columns. And what is unique about mapping SDKs is that they allow you to query things in a spatial way, and that's just really unique. It really does make location a very first-class citizen, and you can do all kinds of interesting things that you can't usually do in a non-spatial data system. So adding a map to this app involved kind of starting with a base map layer, the ocean base map, and this is a base map that stays the same, so it's pretty static. And then we had a second layer on top of this which contains all of the 52 million data points. And these 2 layers get added to the map on startup, and then as people toggle the slider, we add and pull down data and display polygons by depth as in response to the user interface. So again, we have this kind of summarizing what I mentioned earlier and how now this applies to the specific app. How do you actually add a map to your app? So you start with an ocean base map, as I mentioned, and you're instantiating an ArcGIS map. You may also want to give it a particular location where you center. So 0, 0 happens to be off the west coast of Africa at a zoom level of 1, so that's the furthest zoom out, the furthest zoom you could get. And then you attach the map to the view. So we're setting the map to the map view. And then we define another layer that we want to pull in, and we add that as a layer. So that's kind of setting up those first 2 maps. And then we need to kind of control how the map responds to touch events. So that could be a double tap, that could be a single tap, that could be a pinch. You know, right now we're attaching a listener, and the listener in this case extends a default map view listener that comes with the SDK. And what's happening here is when someone taps on the map, the coordinates we get back are screen coordinates, not geo coordinates. So we need to convert the screen points to a geometry or location. And that's where our SDK converts that. And we get now a geometry point that has an XY value, and we can now do something interesting with that value. We can hand it off to the presenter and start querying the data sets. So in this case, this is a close-up view of what you would see if you kind of zoomed in all the way. Those pink circles in that blue square are essentially the columns themselves separated 27 kilometers across the ocean. So it's likely that when you're tapping, you're going to miss one of those points because it's likely. I mean, so how do we ensure that you actually get one result back? So what we do is we build a polygon around the point that you tapped on that guarantees that you'll have at least one result coming back. And so we build a polygon using the geometry engine of a particular size to ensure basically that we cast a wide enough net when we're querying to get at least one result back. So we set up some query parameters. We use a buffered polygon to kind of set that. Here again is where we're querying with spatial data. We're querying with a geometry. So what does this thing intersect? And then we load the table and execute an asynchronous query, and then do more processing on that data to show you the point. But because I might be getting more than one result back, I need to calculate which is the closest pink dot. Since I could possibly get as much as 4 or maybe just 1. If I get more than 1, I need to figure out how far, or the closest one to the place I tapped. And so here we go and get the center of that buffered polygon, the circle, and then for each data point coming back, I've transformed that into a model object called a water column, and I'm getting the center of that water column and then calculating the distance between the pink and the center of the buffer, and then sorting my columns and showing the one that's closest. So that's just a real kind of specific and very accurate way of determining distance. And again, it's part of the SDK that we make. So here's an old school UML sequence diagram. Hopefully some people recognize what this is. Just a summary slide to kind of show how we've divvied up responsibilities between the view, the model, and the presenter, and what happens when you tap on the map, and how those responsibilities are handed off to various parts. So I've always liked sequence diagrams. Always try and show them. So for testing, I used Robotium, which is a black box kind of UI testing framework. And I wanted to be able to kind of run through some UI tests to make sure that changes I made weren't breaking anything. And so I chose this as a first place to start, being new to testing. so what's kind of nice about it is you don't really have to know too much about the app. So anyone else could write these tests. It doesn't have to be the developer. They just have to know that when you press this button, this is what's supposed to happen. And so it was pretty easy to write the UI tests. And one of the things I liked is in Robotium, you can generate screenshots of your test results. So as the app is doing stuff, you basically run the tests. The app does all the testing, and as it's doing it, you can actually have screenshots automatically saved on your device and review them after the test to kind of make sure, another way to kind of check that everything's as expected. So, okay, so the drawback was Robotium doesn't, it's not JUnit testing. It's not like testing the logic of the presenter and interactions and integration explicitly. And that was something I struggled with. I tried to figure out how to do that, and I ran into problems with, it felt like I had to do a lot of mocking, but I couldn't mock classes that I don't own, like some of these service classes, and that just, it kind of quickly got very frustrating. So I feel like I failed on that in terms of thorough testing. And then because this, this map is relying on the network, and that's all the data is coming down through the network, and also the map itself is a complex view, so it takes time to load, and there's an asynchronous nature to these interactions. I found that hard to also break down into testing, and it didn't feel like I had a good strategy for testing that. And I also realized as I was trying to build tests, that I didn't do a very good job of managing my dependencies. And so that was one of the kind of clear lessons that I walked away with, was like, for example, my data manager, it uses all these service tables, all these services, but it creates them on its own. Like it creates them inside the data manager class, and it's hard to then pass those in as dependencies. And as I mentioned, mocking was really difficult because there were lots of classes that I didn't own that then couldn't be mocked. So like the map view, or the service tables I couldn't mock because I don't own them. But I guess there's ways around that too. And so I'm starting to kind of figure out next time I do an app, or after this app, I started to take this kind of learn from my mistakes and started to use dependency injection to kind of set myself up better for testing. So there are lots of other example or apps that use maps out there, and these are all open source. They're all available on GitHub. Almost all of these use MVP. Some of them also have Dagger for dependency injection. So it's kind of a good place to go, I think, to kind of start to look at how to use mapping SDKs. And you can use these apps as is, or you can take them and make them more extensible. So I encourage you guys to look at these. And we also have them on other platforms for anyone who's interested in iOS or even .NET. And that brings us to the kind of conclusion lessons learned slide. So as I mentioned at the start, this open data set allows us to kind of understand more deeply about ocean conditions and ultimately help us manage the oceans better. And this app is centered around a complex view that can be responsive if you don't put it in multiple activities. So we had one activity for the map and for the entire app, and that seemed to work well for app responsiveness. And I'm really curious, like, what other strategies people have used to get around this problem. Like, I'm sure I'm not the only one who's run into this, so I really would love to know how people deal with complex views in activities and fragments. So really like to hear if you've done any of that. And we showed how these big data sets can be used to kind of display data pretty easily and provide contextual information. And then kind of my own discovery was that app testing is really difficult in Android, and even though you do MVP with the best intentions, that's not always enough to kind of set you up for testing. And then here are some resources I use. The charting library was awesome. It was an open source MP Android charting library. really, really nice, flexible library. And I mentioned the Android Blueprint architecture repo, and then the Robotium tools, and then our own sites for exploring more about maps and looking at some samples. And thank you for your time and attention, especially the last session of the day.